Machine learning, or ML, can help solve a variety of business problems across many industries. An example of questions that ML can help a data scientist answer are: is this internet traffic pattern indicative of a hacker? Does this mammography scan show signs of cancer? Or, how many days before this manufacturing part fails? A data scientist must choose the type of ML algorithm to use. This decision is mostly dependent on the type of data available to train the model. If the training data includes both features and labels already defined, then you can use a supervised learning algorithm. If the training data does not include labels, then you would use an unsupervised learning algorithm. Let us take a closer look at both types of algorithms. Supervised algorithms. Linear regression. Linear regression algorithms aim to learn the correlation between a set of input features X and a continuous output variable Y. The goal of the algorithm is to be able to predict a continuous numerical value. For example, a manufacturing engineer, knowing the number of weeks before a critical component fails, is valuable, allowing them to proactively schedule focused maintenance, thereby reducing downtime. Classification. A classification algorithm's goal is to understand the relationship between feature data and an output label. The end result should be the ability of the ML model to separate the data into distinct groups. For instance, to predict customer sentiment, a company can collect data such as age, gender, purchase history, and customer service interactions. The ML model can then use that data to compare how other customers with similar features felt, and then label their sentiment as happy or not happy. Unsupervised algorithms. Clustering. Clustering algorithms analyze unordered input data and attempts to label them into discrete groupings. In this case, the unordered items have been analyzed and labeled into 3 groups: fish, sheep, and cats. The number of groupings and the group labels are unknown and part of the problem the ML model solves. For example, a clustering algorithm can be used to determine what trending subjects are being discussed in an organization's social media posts. Then cluster them into topics such as an upcoming merger, a new product launch, or a service outage, so they can be addressed by management. Anomaly detection. Anomaly detection algorithms help solve a special type of ML problem where the number of clusters is 2. This type of algorithm excels at finding unusual activity in large datasets. Detecting intruders in a computer network by analyzing log data is an anomaly detection problem. Unusual activity would be labeled as anomalous if it departed significantly from normal patterns.